Hello and welcome to today's lesson, a review of mean value hypothesis tests. So in this situation, we've already gone through our hypothesis testing unit of mean values once before, and we're just going back and reviewing probably one of the main topics that you're guaranteed to see in a free response question on the AP exam. So now, when we're looking at the problem, we always want to pull out all of our information first. We want to know what we're looking for, what we're trying to do. And when they ask for is something significant, okay, they'll never usually come out and say calculate a hypothesis test. But when they ask for significance, the hypothesis test is what we use to prove the significance of that situation. Okay, so you're always looking for pulling out your mean values and your standard deviations. Okay, remember, in this situation, we're looking at a t-test, and a t-test happens because we have a sample standard deviation, S of x, instead of a population standard deviation, which would be sigma of x. Okay, so this is based on sample size, sample standard deviation. Okay, you're pulling out either the single value or the two values. Okay, the next thing that you want to do, you pull out all of your information. You want to tell the person that's reading your question what type of test are you doing. Are you doing a one sample hypothesis test because you only have one mean, one standard deviation? Or are you doing a two sample hypothesis test because you have two independent means, two independent standard deviations? Okay, so when you're doing that, once you've stated the type of test, then you always want to go in and start to build your null and alternative hypothesis. Now, these nulls and alternatives are always based on what we call mu of x. This is the population value that the sample is representing. We're using x bar, a sample standard deviation, to represent this mu value. And remember, you always have to define what mu of x is overall. Okay, so you're going to be given some value, some number in the problem that they want you to test for the claim, and then your alternative is based on the wording of the question. Do they believe that our sample is greater than the claimed value, less than the claimed value? If they don't give you one of those two, then you have to go with a not equal to alternative. Okay, so all of this is based on the wording of the individual question. You're usually reading that last sentence, and that last sentence will tell you what it is. And we use the same number in both places. Okay, so you've got your null, your alternative, you've defined it, you've said what type of test you've done. All of this is one of 4 points when they're going through and grading you on your individual question. If it's a two sample, you have a couple options for your null and alternative. Okay, we'll look at both of those possibilities. You can compare the two. You know, mu1 equals mu2, and then you would have mu1 greater than, less than, not equal to mu2. So that's one option. And then you have to define both, your mu1 and mu2 value. Or you can work with what's called a mean difference. So your null would actually be mu d, and we always assume that there's no difference because they're equal to each other. And then your alternative would be the mean difference is greater than, less than, or not equal to 0 based on the context of the problem. And then in this situation, you have to define what mu d is. Okay, you're pulling that information out of the question overall. Okay, but remember, this is just quick information that you pull out of the problem, and now you've already got 1 out of 4 points for the question overall. Okay, your second of 4 points comes from verifying your assumptions. Can we trust the data that we have to give us a reasonable solution overall? And as soon as some of our assumptions fail, we still keep working. We just know that our answer isn't as trustworthy as we would want it to be. Okay, when it comes to random, you just search through the problem and find where they state random sample of blank stated in problem. Okay, so you have to make that statement of your assumptions. You know, make this a separate part. You've done your null and alternative hypothesis. You have that in one part of your answer. Okay, you want to have the heading of assumptions and work through our random, independence, and normal. Okay, when we're looking at independence, it's always, you know, and if we look at independence and normal, we kind of call this the Goldilocks idea. We don't want a sample that is too big. So that's when we do our n times 10 less than the population, knowing that our sample size is less than 10% of the overall population. Okay, you want to plug in values to prove. Okay, and the other part of independence, when we're doing a two-sample problem, we have to show that the two samples are independent of each other. Okay, so it's a lot of times stated in the problem, two independent samples. Okay, so when you're looking at that two-sample situation, you have to be able to understand and define that they're independent, because if they are dependent samples, we actually have to do a different procedure. Okay, and we'll talk about that procedure in the next lesson. Okay, and then the last part is proving that you have a normally distributed sampling distribution. Okay, so for your normal distributed sampling distribution, okay, you could be told in the problem. This is the best case scenario. Okay, you're told in the problem that it's a normally distributed sampling distribution. You just copy that sentence into your assumptions. Okay, the next easiest process is based on sample size. Okay, so a large sample size, n greater than 30. Okay, we can use the central limit theorem to assume a normal sampling distribution. Okay, and then the most difficult way, okay, in a mean value problem is you would have to graph the data. Okay, and this happens when it's not greater than 30 and you're not told that it's normal. And the graph that we're looking for is a box and whisker. Okay, and when you do the box and whisker, you're going to sketch that onto your page. And then with that sketch, we're just looking for no outliers or extreme skew. Okay, and when we're talking about an extreme skew in a box and whisker, you know, we're looking at something like this. Okay, that would tell us that we're not necessarily dealing with a normal sampling distribution. Okay, so now we've stated our null and alternative hypothesis, we've written our context, we've tested our assumptions, and you already have half of the points for the problem, and you haven't done anything calculation-wise at all. Okay, and that's the important part to remember about statistics. It's a lot about verifying, setting up your process, where your calculations are usually only one of the 4 points for the problem. Okay, now remember, everything that you need calculation-wise is on the formula sheet. Okay, backside of the formula sheet given to you for the test gives you your test statistic formula. And we want to remember in mean values, when we're given a sample distribution, we're finding a t-value. And our t-value is going to use our x bar minus the mean value from your null hypothesis, whether it's 0 or a specific value, and then divided by single sample standard deviation. Okay, we just copy over that formula. And then we built our t-value. Okay, now if it's a 2-sample, okay, a little bit easier for a 2-sample situation. There's more work required on the front end to get some of the values, but our t-value is always going to be minus 0 because we're assuming that there is no difference between these two values. Okay, but we do have that larger standard deviation formula that we have to build in. First, standard deviation squared divided by sample size. Second, standard deviation squared divided by sample size. You have to show these calculations on your page. Okay, even if you use the tests in your calculator, okay, and I'll show those quickly here in a little bit about where you can go. Even if you use those tests in your calculator, if you do not show this work, you will not get full credit for the calculations port of the question. Now, once you found your t-value, the next thing that you have to do is write a probability statement. Okay, a probability statement doesn't require much. The calculator is going to do a lot of the work for us, but we want to remember what a probability statement is. Okay, it is the probability if the null hypothesis is true of getting a result as extreme or more extreme than the given statistic value. Okay, so when we're always looking at this distribution, the center of the distribution is our null hypothesis, what we're assuming to be true, and then our statistic value is either going to fall on the upper end or lower end, and we're finding the probability of going to the extreme, or we're finding what we call a tail probability. So it's just the probability of t being greater than, less than, not equal to, okay, your given t-value that you found, and then we use the calculator to find the answer for us. Okay, we don't have to do that by hand. The important part here is you don't want to type in a calculator operation. You actually want to type in something that's a lot simpler than the calculator operation, which is just our basic probability statement. And when we think about it, you know, if we're getting a probability that's very small, that's why we reject. The chance of this happening is so small that we can assume that the null hypothesis is not true, okay, and we reject that value. Now, when you're going to your calculator, how do we get that p-value? Remember, it's a second vars, or it's a distribution calculation, and we're doing a t-CDF, and then you always need your upper and lower boundary and degrees of freedom. Okay, so we would plug in those values to get the probability for this given situation. You know, so I can run through and finish based on these numbers that are here. Okay, and we see that probability value. Okay, you know, 0.6 or 0.7%. So this would be so rare that we would reject based on this given probability. Okay, probability value less than 1% overall. Okay, so now we've finished our calculations. We've written our probability statement. We did not copy what we typed into the calculator. They won't grade that because there are multiple calculators that people can use. A lot of people use the TI, but not everybody. Okay, so we have that situation. And then the last part is your conclusion. Okay, conclusions for significance tests never change as far as what's required of you overall. Okay, first thing that's required is state your evidence. Okay, what's leading you to this conclusion? Based on my p-value compared to a significance level, my p-value is smaller. It's a rare situation. So when it's rare, we reject. If it's not rare, something that happens 20% of the time, 30% of the time, that's when we fail to reject. Okay, so you make a conclusion about the null, and then you're going to make a statement about the alternative in context. Okay, so once again, these are cookie cutter situations. Okay, all you have to do is memorize this format, and this format will help you get full credit for your conclusion. Okay, based on our evidence, your p-value compared to a significance level. Okay, state that in the problem. We reject or fail to reject the null hypothesis. This evidence supports or does not support the alternative. We never accept the alternative. Okay, we just want to support or not support the alternative hypothesis, which states, and this is the thing that's going to take a lot of work, you actually have to write out in words what the alternative hypothesis is. The mean value of X trials of this situation is greater than 12. Okay, now, when we look at the situation, you're trying to get maximum credit in an FRQ problem. Let's say worst case scenario, you're struggling with calculations and probability statement. What you want to do in that situation to help you get full credit is make up a number, make up a probability so you can write a conclusion. Okay, they'll let you do that. You'll lose your points for the calculation side, but you can still get full credit for your conclusion, okay, if you have some number and you write a proper conclusion based off of that value. Okay, and finishing up, okay, some extra practice here. We also have our Schoology quiz for this lesson, okay, but in the in-class packet, a chance for you to see, work through examples, the hypothesis test problems, 1, 3, and 4. Okay, so it's usually the second half of those or all of problem number 4. Thank you and have a good day.